Okay, the next two theorems we're going to learn are called the fundamental theorems of calculus. So this is really what calculus boils down to. So this is the fundamental theorem of calculus part 1. So it says if f is continuous on a to b, then f of x, so we're creating this new function where we say big F is equal to the integral from a to x of f of t dt. That means if you want to plug in x, you're going to plug in a number there and actually do that integral. It's continuous on a to b and differentiable on a to b, and its derivative is f of x. Then the derivative of big F is equal to the derivative of this integral, which is just f of x, just plugging x into here. So what this is really saying is that the derivative of an integral is the integrand. Okay, so we're saying if you take the derivative of an integral, and we had to make this a function that has to be a variable. If you put a number up there, then the definite integral would just be a number, a constant, and the derivative of a constant is 0. So if you have this function that's an integral, that the derivative of the integral is just the integrand. So you're going to plug that value of x in there. Now we will have to see that sometimes we'll use chain rule. So here's how we're going to do this. So it says evaluate the following. The derivative of the integral from 3 to x, the square root of 1 plus t squared. Well, by the fundamental theorem of calculus, part 1, we just have to plug in x for t. So our answer is the square root of 1 plus x squared. So you can kind of think that the derivative and the integral kind of cancel each other out. Okay? Now, number 2 here, notice that what we have up here is not just x, it's a function. So here we're going to have to use the chain rule. So the first thing we're going to do is we'll plug in the sine of x for t, and then we'll have to multiply by the derivative of sine of x, which we know is cosine of x. So our answer here will be 5. Putting it into t squared would be sine squared of x times the derivative of sine squared of x, which is cosine squared of x. So that would be our answer. Now, one more thing I kind of want to show you is that here, if we're taking, let's say we had something like this, and it was x down at the bottom, and then 5 of sine of t dt. Now, if we wanted to take this, the first thing we need to do is notice from the rule the constant is at the bottom. So the first thing we would need to do is we could switch this by putting a negative out in front, 5x sine of t dt. So then we're just going to have a negative out front. Then we would put the x in for the t, so we'd have sine of x. And that would be our answer.